Have you ever hit send on an email or jumped on a video call and just paused for a second? Every single time, you're kicking off this absolutely incredible journey. So, in this explainer, we're going to follow one little piece of your data as it travels from your screen, zips across the entire globe, and lands at its exact destination. It's a trip that has its own maps, its own rules, and some seriously clever ways of getting there.
Now, really, think about it for a sec. How on earth does your video call find just one specific person out of billions of devices connected to the internet? It's not just getting blasted out into the void, right? There's a system, a kind of digital intelligence that knows precisely where it's going. And that is exactly what we are going to unpack today.
All right, to make this whole thing super simple, let's use an analogy. Just imagine that all of your data, we're talking emails, video streams, even that cat meme you just sent, is a letter. And the internet? Well, that's just the biggest, most complex postal system you can possibly imagine. If you keep that idea in your head, everything else is going to click right into place.
So, it turns out that pretty much any communication, whether you're sending a letter or sending a data packet, follows these 5 basic rules. You've got the message, that's the actual letter. You have a sender, that's you, and a receiver, your friend. The medium is the physical path it takes. Think of all the wires and fiber optic cables crisscrossing the planet. And probably the most important piece of the puzzle, you have the protocol. This is the shared set of rules, the how-to guide that makes sure your message is addressed correctly and doesn't get lost along the way.
Okay, so our data is a letter, and we know the basic rules, but the first thing any letter needs is a map, right? You see, the internet isn't one single network. It's this mind-boggling collection of smaller networks all talking to each other. So let's explore this digital map, starting right where the journey begins, in your own home. The journey always starts on a local area network, or what we call a LAN. This is your personal network, the one in your house, your office, your school. It's what connects your computer, your phone, your printer, all your local stuff. In our mail analogy, this is basically your neighborhood post office. It's the first drop-off point for your letter. From that local post office, your data might hop onto a metropolitan area network, a MAN. Now we're talking about a network that covers a much bigger area, like an entire city. This is probably the network that your internet service provider runs. So think of this as the huge central mail sorting facility for the whole city, connecting all those little neighborhood post offices together. And finally, we zoom all the way out to the biggest scale there is, the Wide Area Network, or WAN. This thing is massive, spanning an entire country or even a continent. This is the international postal system, the whole shebang, that incredible web of undersea cables and satellites that connects the entire world. So we have our letter and we have the map. Awesome. But how does the letter know which roads to take to get from one city to another? It needs a navigator, right? A digital rulebook. And that, my friends, is where the network layer comes in. The network layer is really the brains of the whole operation. It takes your data and chops it up into little pieces called packets. Then it slaps a header on each one. You can think of that header as the address on the envelope. It's got the destination's IP address, which is like a totally unique digital street address. This layer then acts like a super smart GPS, using that address to figure out the best path for each packet to take across all those different networks. Okay, so we've got our map and we've got our GPS. But, just like with real mail, there isn't just one way to send something. You can send a private, sealed letter, or you could send out a bunch of flyers to an entire neighborhood. The internet has these different delivery options too. At the end of the day, there are 3 main ways to deliver a message online. You've got unicast, which is a direct one-to-one deal, just like sending a private letter. Then there's multicast, which is one-to-many, but for a specific group, kind of like a newsletter that only goes out to subscribers. And finally, you have broadcast, which is one-to-all, like a flyer that gets dropped in every single mailbox in a local area. Let's start with unicast, because this is the one you use like 99% of the time. Every single time you load a web page, your computer is having a private one-to-one conversation with that web server. The network's only job is to find the single, best, most efficient path for that conversation, just like a mail carrier finding the quickest route to deliver one specific letter. Now, multicast. This is where things get really, really clever. Imagine a huge live stream. Instead of the sender having to send 1,000 separate copies of the video, it just sends it once. The network itself is smart enough to duplicate the message, but only when the path to different viewers splits off.
This is incredibly efficient, making sure that data gets to everyone who's subscribed without causing a massive traffic jam on the internet. And last up, we have Broadcast. Now, this is a powerful tool, but it's very localized. A device sends a message to a special broadcast address, and every single other device on that local network gets it. It's basically the digital version of shouting in a room. You wouldn't do it across the entire internet because, well, that would be absolute chaos, but for local announcements, it's perfect. All right, that was a lot of theory, but let's connect it all back to you. How do these different routing methods actually pop up in your daily digital life? You might be surprised. Let's look at a few common examples.
Okay, first up, you type a web address into your browser, you hit enter. What kind of communication do you think is happening there?
Yep, you got it. That's a textbook example of unicast. It is a classic one-to-one chat. Your device sends a request to one specific server, and that server sends the web page data right back to you and only you. Simple. Okay, now let's think bigger. You're watching a live concert or a big gaming tournament online. You and thousands, maybe even millions of other people are all watching the exact same thing at the exact same time. That is the absolute magic of multicast. The source sends out one single, high-quality stream, and the network does the heavy lifting, efficiently delivering it only to the people who tuned in. It saves a truly incredible amount of bandwidth. Without it, the internet would just grind to a halt during big events. All right, here's one you might not even think about. You bring home a new laptop, you connect it to your Wi-Fi for the very first time. It needs to figure out what other devices are on the network, like your printer. How does it ask? It uses a broadcast. It basically sends a message out to everyone on your local network, your LAN, and shouts, "Hey, I'm new here. Who else is around?" It's the perfect way to get everyone's attention in a small, contained space. So there you have it. From a simple web page request all the way to a global live event, these routing principles, unicast, multicast, and broadcast, are the invisible logic that makes our entire connected world possible. But here's the big question to chew on. As billions, and I mean billions, of new devices join the network, everything from our cars to our coffee makers, how will these rules need to evolve to handle that unimaginable scale? That's the challenge for the next generation of the internet.